boys and girls. Today we are going to be working on chapter 13, and this is lesson 8 on composite figures and how we can find the area of composite figures. And you might be thinking, well, what's a composite figure? So a composite figure is when you take two or more shapes and you put them together to make one shape. Okay? And for this lesson, both of the shapes we're going to put together are going to be rectangles. So it might not look like a rectangle, but we can break it apart so that it's made up of rectangles. So we're going to start with this little short video clip that comes with all of our lessons. So I'm going to start us off there.
Explore. Use models to find areas of composite shapes. You have used square units to find the area of rectangles and squares. You can also use square units to find the area of other shapes. For this shape, we need to find the area of the shaded region. One way is to count the square units. The shape shows that there are 48 square units. Another way we can find the area is to decompose the shape. First, decompose the shape into rectangles and squares. The shape can be broken into 2 rectangles and 1 square. Next, we need to find the area of the parts. Then we can add them together. Let's begin by finding the area of the first rectangle. 3 times 5 equals 15. Next, find the area of the square. 3 times 3 equals 9. Finally, find the area of the second rectangle. 6 times 4 equals 24. Now, add the areas together. 15 plus 9 plus 24 equals 48. So the area of the shape is 48 square units.
So let's begin our lesson. This is area of composite figures. We're going to skip over the problem of the day. All right, so here we're going to find the area of the rectangle. This is just a real quick check because in order to do this lesson, you need to remember how to do some previous lessons. So you'll notice that neither of these rectangles have the squares in there to count. So we do have to rely on multiplication here. But I can multiply 3 times 6 and get 18 square feet. And then I can multiply 2 times 4 and get 8 square meters. Okay, so you do need to remember how to find the area of rectangles, especially when you don't have squares or a grid to count. That will come in handy when we're doing today's lesson. All right, let's start here. So we are going to look at the composite figure shown. This here is our composite figure. And we're going to draw a line to decompose that composite figure into 2 rectangles. And then we're going to find the area of each rectangle so that then we can add them together to find the area of the entire composite figure. So I'm going to look at this and I'm going to see that the length of this side is 2 centimeters. The length down here is 9 centimeters. Here's 5 centimeters. Here's 6 centimeters. So I think what I want to do is I want to decompose this rectangle like this. Okay, I think that's just going to be a little bit easier. I could totally do it a different way. I could do it this way. I could decompose it that way. But for this example, I'm just going to make it a little bit easier on myself. Okay, so the area of the rectangles, I've got this rectangle here, which has an area of 2 centimeters times 6, which is 12 square centimeters. And then down here, this second rectangle has an area of 5 centimeters times 9 centimeters, which is 45 square centimeters. So then when I add them up, I get 12 plus 45, which equals 57. 57 square centimeters. Now, I told you that I could have decomposed this rectangle going that way. Let's see if we would get the same answer. We should get the same answer. The reason it's a little bit more challenging to decompose your rectangle this way is because you have to do a little figuring, because we don't know the length of this side. Now we can figure it out because I know that from here to here is 6 centimeters and from here to here is 5 centimeters. So I can do a little math to figure out that the length of this really long side is 11 centimeters. It just doesn't, the problem just doesn't tell me that. I have to do a little extra math here. I know that the length of this side is 5 centimeters, so then the length of this side is 5 centimeters, but I don't know what the length of this side is. I know across the bottom it's all 9, but really I only want this much of it. I know that the length of this side is 2 centimeters, so I can use math to figure out that this side is 7 centimeters. So if I'm doing some multiplying, 5 times 7 is 35 square centimeters, and 2 times 11 is 22 square centimeters, and 35 plus 22 does still equal 57. Decomposing it this way just made it a little bit more challenging because I had to figure out the length of a couple of sides. It's totally possible, it's just a little more challenging. All right, let's move on. Ooh, this is a tricky one. This one, we have to decompose it a little bit differently because you'll notice we've got 3 different rectangles here. So let's see how we want to do this. I know that the length of this side here is 10 feet. The length of this is 12 feet. I know that the length of this side here is 5 feet, and the length here is 4 feet. So I need to decompose this in 3 different rectangles. And I want to make things easy. I always want to do it the way that's the easiest for me to do. So I think, let's try this. I think I'm going to decompose it that way. And then, let's see, maybe I will decompose it this way. Let's try that. I see 3 rectangles. There's 1, 2, and 3. All right. So I know that this part here is 4 feet. This one's a little bit trickier because I don't really have all of the lengths that I really truly need in order to solve this. So I'm going to look at this maybe a little bit differently. Let's just pretend that that's one big rectangle. Let's forget about this little part that's chunked out. I can use my fact table and multiplying by tens to know that this whole rectangle is 120 feet because 12 times 10 equals 120. Okay? I also know that this chunk that's really kind of cut out of it is 4 feet by 5 feet. Well, 4 feet by 5 feet equals 20 feet. So if I have a rectangle that's 120, but I take out a chunk that's 20, then I know that the area of this composite figure, this orange figure, is really 100 square feet. So sometimes I can use subtraction to help me figure things out when they're a little bit trickier. All right, let's move on to our lesson. If you are following along in your book, you're going to be looking at page 797. All right. At the top of 797, it just defines a composite figure, and it says that a composite figure is made up of 2 or more figures, and to find the area of the composite figure, you would decompose it into 2 or 3 smaller parts, okay? Here we have a garden. And in this garden, shrubs, trees, flowers, and plants can be bought. What is the area of the nursery's garden at the right? So the garden isn't a perfect rectangle. Most spaces aren't perfect rectangles, but we can decompose it and we can break it up into smaller parts. So we're going to be on the lookout for rectangles. Okay, I see a rectangle. If I were to divide it right here, that would give me this rectangle and this rectangle. I could also divide it here, and that would give me this rectangle and this rectangle. There are different ways that you can do it. Okay? So it's probably easier just to decompose it like this. Draw your line here, and that's what is shown here. This side of the garden, this rectangle, is 8 by 10. This part of the rectangle, this part of the composite figure, this rectangle, is 12 by 8 yards. Okay, you might need to use your fact table to figure this one out. So now what we need to do is we need to think about our formula for finding area, that length times width is equal to the area. So here we have rectangle A is 10 times 8, which equals 80. And rectangle 2, the length times width is 12 times 8. We can even decompose that if we're not really sure what 12 times 8 is. 10 times 8 is 80. 2 times 8 is 16, so you get 96. And then you're going to add 80 plus 96 and get 176 square yards. So the area of the nursery is 176 square yards. All right. Let's take a look at the second example. In the second example, we can look at this in a couple of different ways. Erase this little line, okay? So we are going to break the composite figure up into smaller parts by looking for rectangles. So when I look, I can see that this could be a rectangle, and this is a rectangle, and this is a rectangle. Okay, so it can be broken up into 3 rectangles. Okay? Now, I need to know what's the length here. I know that this whole side is 10 meters, but what is just that little part of it? Can you figure that out? The diagram helps us because I know that this length here is 8 meters. And then if I continued on, it's 10 meters. So 8 meters plus something equals 10 meters. Did you figure out that it's 2? So this rectangle has an area of 12 meters times 2. 12 meters times 2. These two rectangles are actually the exact same size. It's 8 meters times 3 meters, and 8 meters times 3 meters. These are actually the exact same. So rectangles 2 and 3 will have the same area. So let's figure it out. Let's do rectangle 1. Let's find the area of rectangle 1. So our formula, of course, is area equals length times width. For that rectangle, it was 12 times 2. And I know you can probably do 12 times 2. In the book, they have us decompose it just to practice the distributive property. We've got 10 times 2 is 20. 2 times 2 is 4. 20 times 4 is 24. So that first rectangle, that part across the top, has an area of 24 square meters. Now rectangles 2 and 3, we're still using the same formula for area. Area equals length times width. Both of those had an area of 8 times 3. And 8 times 3 is 24. Okay? The next part is then adding all three sums together. So 24 for rectangle 1, 24 for rectangle 2, and 24 for rectangle 3. So the area is 72 square meters. All right. So we'll end our lesson today with the guided practice. So it says to find the area of the composite figure and show your work. So if I were going to find the area and show my work here, I'm going to draw my line, breaking it up into my smaller rectangles, okay? And I can see that this rectangle has an area of 7 times 3. So 7 times 3, and that equals 21. Now this one's a little more challenging because, again, I have to figure out what is the length of this side. I know that the length of this side is 4 centimeters, but I have to do a little math to figure out what's the length of this part. Well, this whole side is 5 centimeters. And from here to here is 3 centimeters. So what am I going to add to 3 to get 5? Did you figure it was 2? Yes. So this rectangle has an area of 2 times 4, which equals 8 centimeters, or square centimeters, pardon me. So the area of this whole composite figure is 21 plus 8 square meters, or I'm sorry, square centimeters, which is 29 square centimeters. For the independent practice, just work through the problems as carefully as you can. When you get to the brain builders, just know that you might have to do a little extra math to figure those out. I'm sure Mom and Dad can help you with those. Thanks, guys, for listening.